Professor Shireen Kanji. And those of you who have come across Shireen's work will find she works at the interstitial spaces of gender, I would say gender, work, employment, and to a large extent, how work in itself is organized. For some time now, those of you who are very close to Brunel would have known that we've just started a massive research center with some massive boost from the university of 160,000 to start a research center in artificial intelligence. And for some few weeks now, I've had a chance to speak to few students and colleagues who are doing AI, and I keep asking, what is AI? Now, what is AI? And you've got a whole lot of explanations and definitions and takes different theoretical perspectives in unpacking AI, what it really is. And clearly the field is a bit, I would say, confused at the moment, obviously, because we are in the pre-paradigmatic stages and we would expect different ideas, and people trying to even define AI has become a bit of a problem. But I'm very sure very soon we will all get to know what really AI is. And before we get to know what really AI is, there are so many concerning issues of which people have picked on, including ethics and how AI will impact on our jobs. The economists have been running a whole lot of commentaries on the possibility of we all losing our jobs and so on. So on that basis, I'm really pleased that we've got Professor Shireen Kanji, who has agreed to speak to us today on AI, data, and ethics. So she's definitely going to touch on some of these issues which have come to dominate contemporary discourse in management and in organizing. So really pleased to have everybody here. It's a small house. The smaller is the friendlier. So everybody should feel relaxed and enjoy yourselves. This is obviously the very last webinar we have in our series. The AACSB committee has been running this series for some time. We've had a whole lot this year, and this will be the very last one for us to go on a break. So we're going to take off all the levers, all the how do you call it, seat belts, everything. Everybody should relax and enjoy. This is the very last one. Really pleased we've got Yehuda here. We will definitely get him on the stump next year. So it's really good we've got him to join us today. Right, so before I get Shireen to start, just a bit of, what I call it, I wouldn't call it housekeeping exercise, really, because we all know the rules here. But the good news today is that Shireen, our speaker, has agreed for her talk to be recorded, which means that the Academy will be able to get you the talk later on, as well as her slides. So you don't have to worry and be frantically trying to write stuff. That notwithstanding, a bit of a warning, as usual, please do not post this on a list server or on YouTube anywhere. It can be a bit difficult to find yourself, in such a situation when you've not given your explicit permission for people to put stuff on social media and so on, and on the list server. But obviously, I'm pretty sure you can share the slide with colleagues for scholarly purposes. I don't think she will mind that much, but please do not host this anywhere else. So the webinar today, the format is very simple. Shireen is going to have about 30 minutes to talk, and she's actually decided to break the talk into segments. So when she finishes with one segment, she may invite some bit of questions here and there, then she will continue. But most importantly, if you have any question at all, please put them in the Q&A box. She will be able to pick them up so that we don't lose the question, neither you also forget the question. And you can also feel free to put the questions in there, which makes life very easy for everyone. I think I'm talking too much. Let me step aside now. So without much ado, I will like to invite Shireen to take the stump now. And Shireen, I commend colleagues to you, and please enjoy the stage. Thank you.
Thank you so much, David, and thank you for the invitation to come and talk at this forum today. I'm very grateful to you, and it's a great pleasure to have you as a colleague. So my talk today is going to be about AI, data, and ethics. Now, that is a rather large topic. My focus is going to be on looking at three things. What constitutes data? How is data collected and classified? How is data processed? And what are the results of the processing of data used for? So of course, I'm going to confine myself to a few examples in each case. But I think this consideration of data is very important for us to be able to understand ethical issues. And the way that I came to this is that I'm an interdisciplinary social scientist. I started off in economics. I moved into social policy. I worked for 6 years in a sociology department. And I've spent a lot of time thinking about inequalities and measuring inequalities. And I've applied a lot of statistical methods in my own research, which have made me really quite fascinated with the nature of data, what constitutes data, and why we have such faith in it. So my talk is going to be in these three parts. After each part, the first part will be the longest part, and after each part, I will pause for a few minutes to collect questions. And also, please feel free, we are a relatively small group, please feel free to ask questions during my talk. So what's happening to data? Well, I think what is really clear is that data is increasing in volume. Each day, the world produces 5 exabytes of data. Well, what on earth is an exabyte? Well, in decimal terms, an exabyte is 1 billion gigabytes. We can't really get our head around this kind of scale, I think, or I certainly can't. But what we can see is that by 2025, we will be producing data at a rate of 463 exabytes per day. So to put that in perspective, in 2009, the world's entire digital storage capacity was just 487 exabytes. So I think by almost any standard, it is clear that the amount of data that is stored and measured is increasing at a massive rate. And this availability of data is changing the ways that we conduct society, the ways that we monitor ourselves, we measure what's going on, and the ways in which we can use data for, for really sort of making step changes in our ability to do things. For example, using driverless cars, in medical applications, in so many vastly different ways. So it's not just, of course, the volume of data has increased so massively. It's also that the types of data that are found are proliferating. We have big data, structured data, unstructured data. So structured data is the kind of data that is in a database that can be queried. Semi-structured data is the sort of data that we might find from social media that is not structured. There are all kinds of different types of data. And I think that the ethical issues, as we start to look into this, the use of these different types of data raise special and different types of ethical questions. So we have all this data. Are we right now to put our faith in data? Because we have data and we've tended to put our faith in data, into data. There's a kind of assumption that data are, we put the cart before the horse. Data come first, that they come before, we come to them. And they are there. There is something sort of holy about data, or there is something unsullied by data. But in a very interesting book by Balker and Starr, they talk about the nature of data and how data are socially constructed. So Jeffrey Balker says in Memory Practices in the Sciences, data are always already cooked and not raw. Our belief in the value of big data and the advantages of machine learning are based on faith in their neutrality. That is, that they are somehow raw. And I think if you look at what people say about data, they do have this incredible faith in data because of the volume of data that is available per se. So I think that we need to spend a little bit of time thinking about what are the presuppositions that precede the collection of data. You know, we have to use our imagination before we even get to the data. Data have to be imagined as data. They don't just exist. And the imagination of data requires an interpretive base. Data produce and are produced by the operations of knowledge production more broadly. So every institution has its own norms and fields. Can you hear me? There was a bit of an echo. Yeah, every field has its own norms and standards of production. How data are cooked in the various aspects of their collection, transmission, and storage mean that it is not always neutral. And that is what I want us to spend a bit of time thinking about. So the very interesting book I was mentioning is this book called Sorting Things Out, Classification and Its Consequences. Now, I want to draw, before I return to that book, I actually want to draw on another example, which I think is really illustrative of the nature of data and how it is developed over time and what constitutes data. So I want to draw on the classification of Linnaeus. I can still remember from my biology lessons at school, this classification that is widely used, which Linnaeus came up with. And I think, yeah, his system, the first edition of his System Naturae was published in 1735. And it identified varieties of humans as comprising a nominal classification because the varieties did not constitute separate species. They were basically drawn along geographical lines. And he identified here under Homo, he put people under the class of quadrupedia, of animals. And that, of course, caused a lot of unhappiness at the time because people felt that this was an insult to God, that actually man had special intelligence and qualities that put him or her beyond the other animals. And so there was some sort of contestation or some unhappiness about his early classification system. Linnaeus classified people into these four groups, Europaeus, Americanus, Asiaticus, and Africanus. He classified these groups because of their different geographical locations, and his thinking was that they differed because of the geographical differences that had meant that they had developed in rather different ways. So those four varieties, he talks about them as varieties of people. They are not ranked in the first edition of the Systema Naturae. But Linnaeus was not oblivious to what his colleagues thought, and he was influenced by the thinking of others around him. And over time, he came up with a number of different versions of the Systema Naturae. Initially, in his first edition, he had hardly said anything about the different varieties of people. He saw them as varieties. He certainly did not see them as subspecies. But by the time, there's some contestation about the translation. By the time we got to the 10th version of the Systema Naturae, he was beginning to distinguish these groups, and his classification changed over subsequent iterations. But he always had Africanus at the bottom. So I think that we can see here, of course, this was in line with European thinking of the time, but he also laid the groundwork in reflecting European thinking of the time. He also laid the groundwork for subsequent scientific racism. I don't lay it all at the hands of Linnaeus. Of course, there are many power interests at play here. But we see that he begins to include manner of clothing, form of government, behavior, physical traits relating to hair color and form, eye color, and distinctive facial traits, as well as skin color, medical temperament, in his subsequent classification, which is a very different classification. In fact, one which is much more in line with more contemporary sort of psychological classifications of race. So I was very interested to see that it was only in 2020, I think it was even just it was either in 2021 or 2022 that the American Psychological Association finally apologized for its own perpetuation of racism. And some of the some psychological works published in well-known journals actually very much sort of reflects this kind of way of thinking about differences. For example, in the work of Rushton, who seems to have produced work that is overtly racist in orientation, but was published in some of the top psychological journals. So why am I taking us off in this direction? You say to yourself, you've come here to listen to a talk about artificial intelligence and ethics. Well, the reason that I'm spending time talking about this is that it is a system of classification. And we have many systems of classification, many of which we don't actually question at all. And Bowker and Starr make the point in their book that these are the ones that we have to be the most worried about. When we see classifications as being completely natural and really not needing any comment, these are the classifications that we really need to try to expose the basis of. They may be fair or they may be unfair, but we need to understand what the thinking is that underlies these classifications. So one of the classifications that they talk about is the ICD, the International Classification of Diseases. And that classification has been going for over 100 years and has had 11 iterations. So we might think that there's something quite sort of natural about having categories such as rare disease, mental health, musculoskeletal health, but there is nothing natural in this. Groups of people have come together to define these different groups over time. And there is a very strong organizational and individual interaction going on in classifying these diseases. And these classifications have implications. They have sort of geopolitical implications, particularly when we look at monitoring disease outbreaks across the world. They also, within particular countries, have resource allocation implications, and they are sort of always being contested, or they are under constant revision because some diseases become less important, some diseases become more important, and our thinking about disease also has changed dramatically over time. So I think if we look here, I'm just showing you this chart to show you that there are these different reference groups that come together. There's a proposal groups, there are reference groups, there's a process of verification. These are all sort of, these processes go through organizations, which is very important for us as scholars of organization to think about how the case is made in these different sort of aspects of the process. So one of the diseases that they specifically talk about in this book by Bowker and Starr is AIDS. And initially, back in 1982, there was an article in the New York Times saying that according to both the Centers for Disease Control and the National Cancer Institute in Bethesda, Maryland, GRID has reached epidemic proportions, and the current totals probably represent just the tip of the iceberg. Preliminary results of immunological tests have led some federal health officials to fear that tens of thousands of homosexual men may have the acquired immune dysfunction and be at risk for developing complications such as Kaposi's cancer, infections, and other disorders at some future date. So in 1982, the climate for gay people was extremely different to the climate of today. And there was a lot of contestation from the gay community. It's gay-related immunodeficiency syndrome, GRID. There was a lot of contestation, and partly it was through the contestation from the gay community that we began to see that this was not a disease that was confined to gay groups. I mean, some people also called it the 4 H's, which meant that it was related to hemophiliacs, homosexuals, Haitians, and heroin users. But this political contestation, there was a kind of political contestation behind the classification of the disease. The classification is not just something neutral, it is something that is part of a process of knowledge production. So that is really the point that I want to make. And I think that that is true in so many different areas. During my talk, I'm going to focus a lot on issues to do with race and ethnicity, because these come up time and again in studies of ethics and applications of artificial intelligence. And I think that, we should really bear in mind that under the mapping of the human genome, it was found that, when the human genome was mapped, that we share 99.9% of our DNA with other people. So I was explaining that to my husband today, that perhaps, it's surprising that even he and I share 99.9% of our DNA. And, it's not just true for us, it's true for all of us. So that picture is just to show that data, what is happening to data? Well, it is fragmenting and it is proliferating, and the whole sort of environment is changing. So data aggregating, in one of the areas that we can see this, really illustrated is in the healthcare sector, which includes the sort of data that is now being produced, includes electronic healthcare records created by public and private healthcare providers, biobank collections, yes, even in Understanding Society, one of the UK's major data investments, which was started, I think, over 12 years ago, DNA collection was part of the survey. The survey had evolved. They are biobank collections plus information generated by medical devices, social media, and data platform companies. And for those of us who work in the area of human resource management, we can certainly see how these forms of data collection are changing all the practices of human resource management, and certainly have the potential to completely transform them. In the public sector, the NHS has access to one of the largest single resources of patient data globally, giving the UK a unique opportunity to capitalise on the deployment of data and data-driven technologies in healthcare. So the UK is sitting on this gold mine, basically, of patient data. And who gets access to the data really gets to have a command over healthcare, because the data is so valuable in making connections and understanding disease that it provides really a remarkable opportunity. And that is why, we really have to be very careful about that data, because as it is, only a few companies have command over most of the data that is available or have some sort of power over it. So that is why it was particularly concerning when Google DeepMind went into a collaboration with the Royal Free London NHS Foundation Trust. And, it was really very surprising in the healthcare area, where usually such care is taken over data, that so much sensitive medical data on millions of Royal Free patients started flowing into third-party servers contracted by Google to process data on behalf of DeepMind. So apparently the reason for this collaboration was that DeepMind was going to develop an app to sort of signal problems with acute kidney disease, acute kidney infection, so that clinicians would be able to identify patients who are at risk. But actually, this seemed like a very limited use of the data. And in fact, it was a very limited use. And the actual intended purposes, or the purposes that DeepMind were using the data for, were rather larger. Okay, so I now want to move away from slightly move away from the question of data, although it will always be with us, to look at the processing of data. What actually happens when large data sets are processed in order to make recommendations and policy prescriptions? So I was thinking about this, Bowker and Starr claim that actually all data is cooked, it isn't raw. I was thinking that perhaps there are, certain degrees of where, of cooking. Some data is more raw than others. In a way, there's not really much problem with the sort of machine learning processing of scans that have already been diagnosed, and putting those scans next to clinicians' diagnoses, and then developing future diagnoses that you can apply to new scans based on past diagnoses. I think that is not so much the case when it comes to criminal sentencing. And in the United States, there has been a significant use, really very significant use of algorithms to calculate risk assessment scores that are used to help judges in all stages of the process of deciding whether people should be released, whether they should be released early, or whether they should be sentenced. So a progressive argument is, well, American populations, the American prison population is so high that actually any tools that help to establish what the risk of reoffending, for example, is, are useful to reduce the prison population. But in the process of reducing the prison population, something that begins to happen is that we get even higher levels of racial concentration of the prison population. So I'm sure that many people here have read the study by ProPublica of prison sentencing, where they looked at an algorithm from they looked at an algorithm called Compass that was developed by a company called Northpoint. And this was, at the time they looked at it, was a new algorithm to conduct risk assessments. And it found that Black people were systematically overrepresented as high risk. The ProPublica's investigation of this algorithm. The algorithm is a trade secret, not subject to scrutiny. What they were able to do, what ProPublica were able to do, is that they obtained all the sentencing data from Broward County, which I think is in Florida, because they have particularly advantageous sort of data transparency laws in that area, in that district. So they looked at the predictions based on And this is where we come back to data again. So one such statement that they looked at, that they used to assess a person's risk of reoffending, is their response to a statement such as, "A hungry person has a right to steal." So I'm sure that many people here on this call do a lot of quantitative analysis and are very familiar with the use of statements like this in conducting our own work. Perhaps we don't use a statement quite like that, but we use statements that are rather qualitative in their orientation. Compass uses the data, are answers that are put out in this questionnaire that consists of 137 questions. And for example, one of these questions is, "A hungry person has a right to steal. When people get into trouble with the law, it's because they have no chance to get a decent job." So what I would suggest is that if we really look at these statements, these are data, and therefore we should temper our faith in data. We're asking people who might be up for sentencing or might have been sentenced, who have come from particular circumstances. There's not really any accident that people who are poorer are more likely to be imprisoned or more likely to offend, or offend in the categories that we currently look at. So if we look, I think it's well known that the US prison population is highly skewed by race. So if we look at this chart from the Pew Research Center, we could see that while Black Americans made up 12% of the population, they made up 33% of the prison population. White Americans made up 64% of the population, but only 30% of the prison population. So one of the things that, one of the implications that Bernard Harcourt talks about in relation to lowering the prison population is that if these risk scores are used, then basically it will lead to much more ethnic race, ethnicity sort of concentration in the prison population. And he says, well, risk today has collapsed into prior criminal history, and prior criminal history has become a proxy for race. So while race and ethnicity is not a question that is asked in these risk assessments and cannot be asked, race is so much correlated with other issues, spatial issues, with postcodes, with income, with many other correlated variables that, in fact, it is heavily taken into account. So ProPublica gave this example of some of the criminal sentencing that came out of the algorithm. And they show two offenders here. There's Vernon Prater and Brisha Borden. Vernon Prater, I think, was in his 40s. Brisha Borden was 18. Well, they both had offended before. Brisha Borden and her friend stole a 6-year-old scooter, or a couple of scooters, and rode off down the road. When the mother called after them, they dropped the scooters and ran off. Vernon Prater was involved in an armed robbery, and he was assessed as low risk, whereas Brisha Borden was assessed as high risk. She did not go on to offend, and he did go on to offend. And you could see that the algorithm had placed her at a much higher risk than him. So I'll come back to this, but I think, well, this is actually an important point, isn't it? That somehow, when we have data, if you look at human resource management, if we look at the people who've been successful in the past, well, they tend to look pretty similar, don't they? and they tend to look pretty similar. And so if we use the past to predict the future, we are kind of stuck in one model. So I said I was going to stop after each point, and then I forgot to stop actually after I talked about the data, but perhaps I should just sort of carry on now. What do you think, David?
Yeah, that's perfectly fine.
Yeah, so I wanted then to go on to talk about a very influential study by Obermeyer and colleagues that was published in Science, and they've been doing a lot of work looking at the allocation of resources, healthcare, private healthcare programs in the US. And I think what is really interesting about their work is that they've been able to work very closely with the insurance companies to look at the allocation of resources in terms of the allocation of high-risk programs. So high-risk programs are all about targeting resources to people who are particularly ill. So the rates of, when we compare white and black populations enrolled in these programs, then the rate of comorbidities for black populations is higher, and actually they suffer higher comorbidities, and they suffer higher sort of problems in each of several areas of health risk, for example, high blood pressure. And so then, if we look at that on the face of it, we would expect if we compare only black and white and people who only define themselves as black or white, not as biracial, we find that actually a disproportionate share of resources are going to white people in high-risk groups. And the reason that Obermeyer et al. Uncovered is that they were using past expenditure or past costs incurred by the insurance company. So this is where I think this is at least one example. There, of course, in all these cases, we could draw on standard sort of social science to help understand the inequalities inherent in these programs. So in this study by Obermeyer, they found that there was disproportionate expenditure to people in high-risk groups who are white, and there was not that the expenditure on black populations was not in line with their risk, and this is because costs have been used as the metric. Now, there is a huge amount of research showing how more middle-class people benefit more from health services. There are a myriad of ways in which this happens. I mean, it's not only in health, it's also in education, for example, in relation to what teachers think about certain pupils, what they think about pupils in certain socioeconomic groups, how they treat them, how they think about girls and boys' performance, how girls and boys think of themselves in relation to what they're entitled to. And so all these different forms of inequality go into explaining why the expenditure for white people who are at higher risk is so much higher than the expenditure on black people who are at higher risk. And of course, they report high levels of satisfaction in these programs because, of course, everybody is used to this inequality. People are not thinking, on average, perhaps people are not thinking, well, we should proportionately allocate resources to the people with the highest risks. They are thinking on the basis of which groups are deserving and which groups are less deserving. So I think this work is very important because they have managed to influence the insurance companies to re-look at their own algorithm and think about, whether that is the right way to be thinking. And they've got a number of organizations to work with them. So Obermeyer says, well, an algorithmic bias is everywhere. Our work with dozens of organizations, healthcare providers, insurers, technology companies, and regulators has taught us that biased algorithms are deployed throughout the healthcare system, influencing clinical care, operational workflows, and policy. Okay, so I want to just sort of, like, in the last part of my talk, I want to talk about some of the really concerning areas that involve the actual operation of platforms or new technologies. The work of Latanya Sweeney has been highly influential in this area, where she looks at what is a black sounding name or a white sounding name. And she looks at how adverts are disproportionately attached to black sounding, how some adverts are disproportionately attached to black sounding names, like opportunities to check someone's criminal record are very often attached to a black sounding name. And she knows that because she's put in her own name and found that names like hers, her name is a very black sounding name, Latanya. There are other names that are more sort of black or white, and then there are names that are other names that are only black or names that are only white in the US context. So she shows how the adverts are adversely affecting one racial group and talks about this in relation to discrimination. The work of Sophia Noble is also very interesting in this area, where she was looking at how she put in some search terms for black girls, and she got a whole load of pornographic images, and was linking this to how young black women feel about themselves when this is the way they are portrayed perhaps on the most influential sort of for media of today. So this is an area that I think we need to think about much more, because search engines, as we know, are selectively showing adverts to different people. Some people are not shown job ads for good jobs. Women are not shown leadership roles. The search engines want to optimize their profit, and that's not always by being fair. So they want to look at people's search histories and associate their names and many other features in order to come up with what they think is the appropriate linkage for that person. So she asks, Latanya Sweeney asks, is online activity so ubiquitous that computer scientists have to think about societal consequences such as structural racism in technology design? And then she asks, well, how is this technology to be built? And obviously there's a lot more work that needs to go into this. One of the other areas that I think is quite, in a more technical way, quite concerning, is this inability to recognize photos of people with dark skin. And this is really important. In a comparison of Mitch McConnell and Barack Obama, the search engine practically blanks out Barack Obama. It's amazing he made it to president, because it blanks him out, whereas Mitch McConnell is made much bigger in a comparison of those two images, because the image recognition is not so good on black faces. So work with Timnit Gebru showed that Microsoft and IBM services that try to detect the gender of faces in photos were near perfect for men with pale skin, but failed more than 20% of the time on women with dark skin. And a subsequent study found similar patterns for an Amazon service. And there was bipartisan interest in regulating facial recognition. Elijah Cummings, who's a Democrat from Maryland, had said racial disparities in test results heightened his concern at how police had used facial recognition during the 2015 president's protests in Baltimore over the death in police custody of Freddie Gray, a Black man. Later, Jim Jordan, a Republican from Ohio, declared that Congress needs to do something about government use of the technology. If a facial recognition system makes mistakes, and those mistakes disproportionately affect African Americans and persons of color, it appears to me to be a direct violation of Americans' First Amendment and Fourth Amendment liberties. So, you know, this is really important, isn't it? If there are differential probabilities of making a mistake, because these are really going to affect your outcomes. So I'm just going to sort of perhaps finish by talking about anonymization, because we tend to put a lot of faith in anonymization. Well, it's all going to be okay because we can just anonymize. And I think people have known for a long time that we can't just anonymize. I mean, I remember undergoing training at Understanding Society, or maybe British Household Panel Survey, where they talked about just how easy it is really to find people, and how that's why, you know, they have to put in place extra protection for particular data sets, because otherwise it would be really quite easy to identify people. So, for example, in 2017, German researchers were able to identify people based on their anonymous web browsing patterns. University College London researchers have shown how they could identify an individual Twitter user based on the metadata associated with their tweets. Yeah, and this well-known case of the fitness tracking app Polar, revealing the homes and in some cases names of soldiers and spies. So if we go back to Latanya Sweeney, when she was a graduate student, she actually purchased the zip code. She purchased the sort of zip codes for a whole district, and the Massachusetts Group Insurance Commission had released data on state employees showing every single hospital visit. So the governor of Massachusetts, William Weld, assured the public that GIC had protected patient privacy by deleting identifiers. So then Sweeney bought the zip code records, and she knew that Governor Weld resided in Cambridge, Massachusetts, and she purchased the complete voter rolls from the city of Cambridge, which had contained the name, address, zip code, birth date, and sex of every voter. And with this data, she was able to locate Governor Weld with the GIC records, or locate where he was in these GIC records that were supposedly anonymized. So only 6 people in Cambridge shared his birth date, only 3 of them men, and of them, only he lived in his zip code. So in this theatrical flourish, Dr. Sweeney sent the governor's health records, which included diagnoses and prescriptions, to his office. So I would really say that that was a stroke of genius, wasn't it? So that is Latanya Sweeney, who's a professor at Harvard. And she actually went on to show that 87% of all Americans could be uniquely identified using only 3 bits of information: their zip code, birth date, and sex. So the idea of personal information is becoming, you know, much more difficult to sort of sustain. So I just want to end. I don't really want to show you this clip, because I'm not going to show it to you. But, you know, there's this clip where Elon Musk says, well, I warned you, but you didn't listen. I warned you of the risks, but you didn't listen. I think that many people are working to try to uncover where the ethical issues are in artificial intelligence. I mean, of course, the reason there are so many ethical issues is that we live in very unequal and unfair societies. But the real danger with artificial intelligence is that, you know, we can fossilize these patterns, and they're not always, you know, we're not always sure. Things seem to be quite natural. They're in a black box. And according to Bowker and Starr, you know, this is a really worrying thing when things are in a black box, when we don't really understand what the basis for our categorizations and classifications is. So I'll end there and be very happy to continue the discussion. Thank you.